Hey guys, welcome back to another Leetcode problem solving tutorial, and in this tutorial I'm going to be showing you guys how to solve problem number 100, which is asking you to identify whether two binary trees P and Q are actually the same. So the solution to this is actually a really nice recursive function, and similar to almost all other tree functions, tree answers, it's recursive. So what I'm going to do is I'm going to think of some kind of example, since the examples they give are a bit basic. So let's just make a tree. So I'll have 1, 2, 3, and we'll put 4 and 5 over here. Actually, let me put 4 and 5 on this side so it's a bit easier to explain. Okay, so let's join up our tree. Remember, a tree is just a data structure which can have 2 nodes under each node. A binary tree, to be specific, because you can actually have different trees which have multiple nodes, but a binary tree has only a maximum of 2 nodes under each parent node. Okay, so this question is basically asking us to find whether 2 trees are the same. So yeah, what I'll do is I will just copy this out and I'll just do it in a different color so we can see. So this is 1, 2, 3, 4, 5. So here are 2 trees, and they are clearly the same, as you can see. And how do we create an algorithm which, given these 2 trees, we want to actually detect whether they're the same? Well, what we want to do is we want to handle this on a node-by-node basis. So we're going to be given the root node of each one, and what we can do is check if these 2 are equal, and if they are, then that's good. But what we really want to find is situations where they're not going to be equal, because that's what really lets us break out of this and determine that they're not the same. Because if you know that 2 nodes are the same, well, that's good. It means that the trees could be the same. But if you know that 2 nodes aren't the same, that means you can just instantly return that the 2 nodes aren't the same, therefore the trees aren't the same. So what we do is we check whether, first thing you should check is the values, if the values are the same, and if they are the same, then that's good. If they're not the same, then we're going to return false. So check values, and once we've done that, well, another thing we should do is, well, let's just say we came down to this node and this node, right? So if both of them are none, then that's also fine, because probably means we just got to the bottom of our recursion depth and we're just checking, and that's good. But if one of them is none and the other one is a value, again, that means that we've recursed down them and we've got to none on one of them, but we've recursed and got to a value on another. So that means that the trees are wrong again. So essentially we're checking for if there's any differences in the given nodes of P and Q. So what I'll do is, firstly, we want to check whether P and Q are both going to be null, because if they're both null, well, the basic idea of how this algorithm works is it checks if these nodes are equal, then it sends both of them down, then compares these 2, sends it down, compares these 2, then it'll just send it down one more. There's nothing here, so both of these are none. So you've reached the bottom of the branch, verified everything above it is valid, so therefore if they're both none, then we can return true. We've reached the bottom of this branch and they've all been true so far, so that must mean this branch is valid. So there's one break statement, a base case. Remember, when we think in recursion, we think in base cases and a recursive case. So there's multiple base cases, and else if, so if P happens to be a value but Q isn't a value, or P happens to be a value, Q is none, or the other way around, Q is a value and P is none, that means they're not the same and something's gone wrong, something is different about the trees. So obviously we've already checked whether both of them are null, so now if we check if P is null or Q is null, this is essentially an exclusive OR, because this isn't going to trigger if both of them are null, because this is already checked here and it returns true. So if this is true, then P and Q are different. This is an exclusive OR, and we can return false. since these aren't the same. And finally, the most important thing, so we've checked for null cases, but now what we want to check is just the value. So if p.val is not equal to q.val, then obviously there's something wrong, and return false. And the idea is that p and q should be at the same position for each call of this function, right? The same relative position in the tree for each call of this function. So if we can just compare them, assume they're the same, and then check based on that, and return these true or false base cases. But now we have the recursive case. This is essentially where the magic happens. We want to check, once the current node has been checked, we check the nodes below it. So if the current node didn't actually satisfy any of these conditions, that means, well, the current node is valid. So the current one is valid, but that doesn't mean all the nodes underneath it are also going to be valid. So we want to check, well, we're just going to return is the same tree, p.left and q.left. See how we're incrementing both to the same sort of lefts. But we check that, and we want to make sure that the p.right and q.right are the same as well. So check if the left and right subtrees are the same. And this is going to recurse all the way down till eventually we hit one of these base cases and then recurse back up. And since it's an AND, the only way for this to return true is the same tree is if all the subtrees are also true. If there's a single false in here, then this entire expression is going to be false. So therefore we're going to end up returning that it's not the same tree. So yeah, this was a nice algorithm I'm talking about, and it's a good algorithm using the same tree. Checking if two binary trees are the same is pretty useful, and it's a simple algorithm, so make sure you understand it. Again, as is usually the case with TypeScript, it's hard to get a very fast solution because it really comes down to the compiler. Like if we have a look at these, you'll see a lot of these are essentially the same first base case, and then we're just checking essentially just this check and this check combined into one, since you're using the condition operator, and then the exact same. So yeah, you can see we've got basically the optimal solution here, exactly the optimal solution here. And yeah, it's just, this is a pretty good solution. Recursion depth is going to just take one for each tree node, so it's O of n space if you include recursion, and it's also O of n time, since we loop through every single node. So yeah, thanks for watching, and this is how you solve Leetcode problem 100 compared to binary trees check if they're the same. See you guys in a future tutorial. Bye.